Hi everyone. Now we're going to look at a problem from linear programming. Linear programming, as the name implies, is when you are faced with constraints and you want to optimize your operations. Say in a manufacturing environment, for example, you have certain machines that are slower than others, and you have a budget being allocated to you for your department. But at the end of the day, you want to make profit, you want to maximize profits. This is where linear programming comes in. How you use the constraints you have, and then how you can increase your profits. Here we are given a problem here. They say express the linear program in standard form. Minimize z equals 3x1 minus 2x2 plus x3, subject to these constraints. These are the constraints now. Subject to the following conditions. These are the constraints. These variables x1, x2, x3, they all mean something. They are the constraints, and they got to be positive. X1 got to be positive, x2 got to be positive, and x3 got to be positive as well. X3 must be greater than or equal to 0. So, but first and foremost, we need to express this problem or these equations in a standard form. As you see them in the moment, they are not in a standard form. Why? Because they ask us to minimize. In linear programming, we try to optimize. We try to increase, make more profits, not to bring in loss to the company. So, what is our first step in trying to maximize these functions? If you look at these two equations we have here, if you are trying to maximize this equation here, this inequality sign, it has to change. In optimization, we use less than or equal to whatever be the number on the other side, on the right hand side, but not greater than. Yeah? We use the less than. We want to make everything, this is what you have been allocated. For example, say a budget 17 million. So you want to make all these parameters here to cost you less than 17 million, not more than 17 million. Just an example. So for that reason, this one going greater than or equal to, we have to change this to less than or equal to. So that's the first thing. And this is equal to. We don't want equal to sign as well. We're going to change this again to less than. So how do you go about that? Let's go on. First and foremost, since we are told to, the problem says minimize, but we want to write it in a standard form. In a standard form, we got to maximize it. Maximize, M-A-X, max. Right? So how do you maximize this one? By multiplying it by minus 1. We multiply it by minus 1, then we maximize it. So now this is going to be, our z is equals to minus 3x1. We are multiplying throughout this equation by minus 1. So the signs will change, only the signs that will change. This was plus, minus, sorry, now it's going to be plus 2x2. This is plus, it's going to be minus x3. So the first one is done. Subject to. Now, here we're going to change this sign as I explained to you earlier on. So how do you change this sign to become less than? We're going to multiply everything again by minus here. So this is going to be minus x1 plus 3x2 minus x minus 2x3. Now instead of equal to or greater than, it's going to be now less than or equal to minus 17. I've done this equation. Right? Now, what do we do about this? This has got equals to sign. We don't want that either. So what do we do? What do we do? Now, we're going to represent this by x1 plus 5x2 plus 6x3 less than 7. And we're going to multiply it throughout by minus 1. Now we multiply it throughout by plus 1. We're going to multiply it throughout by minus 1. It's going to be minus x1 plus 5x2, minus, here again, minus 6x3 less than or equal to minus 7. Because it's plus sign. We don't want plus sign. We don't want greater than. We want less than. So you see now the equation, everything is less than. But when you look at these equations, we got 3 variables here, x1, x2, x3, and we only have 2 equations. There's no way you can get an answer to this. So we need to do something else. We now have to introduce what we call slack variables. They call them slack variables. Where do we introduce them? We introduce them on the x3 because we have 2 equations, 3 unknowns. So the last unknown, which is x3, that is where we introduce our x variable, our slack variables. Let's say our slack variables, we call them x bar and x hat. These are our slack variables, SLACK. Slack variables, SLACK. Let's say we call them x bar, x hat. Now we need to introduce them here. Now we will have them in this equation here. Z equals minus 3x1 plus 2x2 minus, instead of x3 now, we're going to have x bar plus x hat. That is what we minimize. Subject to, we have this condition here, minus x1 plus 3x2 minus 2x3, minus 2x, instead of x3 now have x bar plus x hat less than or equal to minus 17. And then for this second equation, we have x1 plus 5x2 plus 6 into x bar plus x hat less than 7. And then again we have the same thing now, is just negative sign, minus 5x2 plus minus 6x bar plus x hat less than or equal to minus 7. So because we have introduced slack variables, we called x bar and x hat, we go to indicate their conditions. So now we got to add here x bar equal to greater than 0, x hat equal to greater than 0. Satisfy these conditions. If we just expand this, I'll now have to erase our original problem. We just expand this once. This is still going to be now z minus 3x1 plus 2x2 plus x3 subject to now minus x minus x1 plus 5x2 plus minus x1 plus 3x2 minus 2x bar minus 2x bar. The minus will affect this one now, minus 2x hat minus 2x hat less than or equal to minus 17. Then I have x1 plus 5x2 plus 6x bar plus 6s hat plus 6x hat less than or equal to 7. Again, x1 minus 5x2 minus 6x bar minus 6x hat less than or greater to minus 7. So this is what they want you to find. This is your answer. That is the answer. Thanks for watching.